Assalamu alaikum students. Let's learn chemistry with Mir Sajad, your chemistry teacher. Today we are going to discuss about the factors affecting ionization energy. जैसा कि आपको पता है कि हमारा जो previous lecture था, that was about the introduction of ionization energy, and in that lecture we have discussed about the two important factors which affect the value of ionization energy, that is our atomic size and the nuclear charge. And we have seen that with increase in the size of atom, there is decrease in the value of ionization energy. And similarly, with increase in the value of nuclear charge, there is increase in the value of ionization energy. And now we will discuss about the third factor on which the value of ionization energy depends, that is the screening of inner electrons. Screening effect, or it's also known as the shielding effect. For example, if we have a multi-electron system, that's an atom which contains large number of electrons. So it's our multi-electron system. This is the nucleus, and these are the shells or energy levels. So in multi-electron systems, electrons are present in all the shells, that is in inner shells as well as in outer shells. So this is our multi-electron system. This multi-electron system contains electrons in all the shells. This is energy level first, this is energy level second, and this is energy level third. So now in this multi-electron system, the inner electrons, these inner electrons will offer a force of repulsion on the outer electrons because electrons are negatively charged. So these inner electrons will offer a force of repulsion just like this on the outer electrons. So this repulsion of the outer electrons by the inner electrons results in the decrease of the nuclear force on these outer electrons. So hence this decrease of the nuclear force offered on the outer electrons due to repulsion of the inner electrons is known as the screening effect or the shielding effect. So we can say that the effect of decrease of nuclear force on outer electrons offered by inner electrons is known as screening effect, or it's known as the shielding effect. Now with the increase in the number of inner electrons, there is the increase in the screening effect. So there is decrease in the nuclear force offered on the outer electrons. Hence when the nuclear force offered on the outer electrons decreases, we can say that less amount of energy is used to overcome this force. So the value of ionization energy also decreases. So hence we can say that with increase in the number of inner electrons, increase in the number of inner electrons, there is decrease of nuclear force, hence there is decrease in the value of ionization energy. So this was about the third effect on which the value of ionization energy depends, that is screening effect. Now there is fourth effect, that is the penetration effect. So fourth one is penetration effect. It must be noted that the value of ionization energy also depends upon the type of orbital from which electron is removed. So value of ionization energy depends upon type of orbital from which electron is removed. As you know that there are 4 types of orbitals, that is s orbital, p orbital, d orbital and f orbital. Now among these orbitals, this s orbital is close to nucleus. It is very close to nucleus. And f orbital is very farther from the nucleus. Farther from nucleus. यानी जो s ऑर्बिटल है ये न्यूक्लियस के नजदीक है, इसके बाद p ऑर्बिटल है, उसके बाद d ऑर्बिटल है और उसके बाद f ऑर्बिटल है. सो जितना ज्यादा एक ऑर्बिटल न्यूक्लियस के नजदीक होगा उतना ही ज्यादा उस पर ज्यादा न्यूक्लियर फोर्स ऑफर किया जाएगा. सो हेंस वी कैन से दैट the s electrons, that is the electrons present in s orbital, are tightly held to the nucleus, then p electrons, then d electrons, then f electrons. So this property by which the electrons of different orbitals are held to the nucleus by different nuclear forces is known as penetration effect. So we can say that s electrons are more penetrated towards the nucleus, whereas f electrons are least penetrated towards the nucleus. So the order of penetration of different orbitals is given as s orbital will be more penetrated than p orbital, which will be more penetrated than d orbital, which will be more penetrated than f orbital. So we can here say that the value of ionization energy increases with increase in penetration effect. Increase in penetration effect of an orbital. So s electrons को रिमूव करने के लिए हमें सबसे ज्यादा ionization energy की जरूरत है, whereas in order to remove f electrons we need very small amount of ionization energy. So this was about the fourth factor which determines the value of ionization energy. Last factor is the electronic configuration. Here it must be noted that the atoms having stable electronic configuration have the less tendency to lose the electrons, hence their values of ionization energy are very high. So atoms with stable electronic configuration have highest or maximum values of ionization energy. For example, if we consider the example of noble gases are also known as inert gases. They are the inert gases. These are the elements of group 18. They are known as inert because their electronic configuration is stable. So hence, because of the stable electronic configuration, in a respective period, these noble gases have maximum ionization energy. So periodic table में जिस ग्रुप की सबसे ज्यादा ionization energy है वो कौन से है? Noble gases है. So noble gases have the highest values of ionization energy. But here the stable electronic configuration do not only mean the fully filled electronic configuration, it also sometimes means the exactly half filled electronic configuration. So there are some elements which have the highest values of ionization energy because of their half filled electronic configuration. We will now discuss about the various trends of the ionization energy, that is trends across the period and trends down the group. So trends in the value of ionization energy. Trends in the values of ionization energy. First of all, we will explain about the trends across the period. Dear viewers, as you know that when we move across the period in a periodic table, there is the decrease in the atomic size. So there is decrease in atomic size, and similarly there is increase in the nuclear charge. As you know that decrease in atomic size tends to increase the ionization energy, and increase in nuclear charge also tends to increase the ionization energy. Hence, these two factors results in increase in ionization energy. But also, as we move across the period, there is addition of more number of electrons, but these electrons are added in the same energy level, so hence there is extent of screening effect or shielding effect. So this little shielding of the outer electrons is compensated by the increased nuclear charge. Hence the overall or the net effect of all these factors when we move across the period is the increase in the ionization energy. So simply we can say that when we move across a period, there is increase in the value of ionization energy. That means in a respective period, group first elements, that is alkali metals, have the minimum ionization energy. So alkali metals have minimum ionization energy, whereas the noble gases which are present at the last of a period have maximum value of ionization energy. So in a respective period, group first elements have minimum values of ionization energy, and the group 18th elements have the maximum value of ionization energy. Now if we take the example of period number second, that is if we move from lithium to neon, there should be increase in the value of ionization energy. But when we observe the values of the ionization energy of different elements, it is found that some exceptional or some anomalous behaviors are shown by some elements. For example, first anomalous behavior is shown by the boron. First exception is shown by boron. Boron has less value of ionization energy than beryllium. जैसा कि हमें पता है कि अगर हम पीरियड नंबर सेकंड की बात करेंगे, पहला एलिमेंट लिथियम आता है, फिर बेरिलियम, फिर बोरान, फिर कार्बन, फिर नाइट्रोजन, फिर ऑक्सीजन, फिर फ्लोरीन और फिर नियॉन. सो जब हम अक्रॉस द पीरियड जाते हैं, देयर इज इंक्रीज इन आयोनाइजेशन एनर्जी. सो बोरान जो है इट कम्स आफ्टर बेरिलियम. सो बोरान की जो आयोनाइजेशन एनर्जी है उसका वैल्यू ज्यादा होना चाहिए एज पर our trend, but it has been experimentally found that boron has less value of ionization energy than beryllium. So boron जो है it shows anomalous behavior. Now why boron shows anomalous behavior? It is because of the more penetration of s electrons in beryllium than the p electrons in boron. For example, अगर हम boron और beryllium के electronic configuration लेते हैं, beryllium जो है its electronic configuration is 1s2 2s2, whereas boron जो है its electronic configuration is 1s2 2s2 2p1. So here in beryllium we have to remove the s electron, whereas in boron we have to remove the p electron, and as you know that p electron has less penetration than s electron, so it will require less amount of ionization energy as compared to beryllium. So boron जो है it shows the anomalous behavior that its ionization energy is less than beryllium because of the less penetration of 2p electron than 2s electron. So this is the first anomalous behavior which is shown by boron. ऐसे ही oxygen जो है it also shows anomalous behavior in the value of ionization energy. Now let us discuss about the anomalous behavior shown by oxygen. Second anomalous behavior in period second is shown by oxygen. Oxygen has less value of ionization energy than nitrogen. यहाँ पे भी अगर हम second period के elements लेंगे, that is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine or neon. Across the period there is increase in the value of ionization energy. So oxygen जो है its ionization energy must be greater than the ionization energy of nitrogen, but experimentally it has been seen that oxygen has less value of ionization energy than nitrogen. It is because of the stable electronic configuration of nitrogen. क्योंकि अगर आप इलेक्ट्रॉनिक कॉन्फ़िगरेशन की बात करोगे नाइट्रोजन की, इन नाइट्रोजन देयर इज द हाफ फिल्ड, एग्जैक्टली हाफ फिल्ड p subshell, whereas in oxygen there is neither the half filled p subshell nor the fully filled p subshell. So we can here say that oxygen has less value of ionization energy than nitrogen due to the stable electronic configuration of nitrogen. So this was about the anomalous behaviors shown by the oxygen and boron in the period second. So this was the periodic trend of the ionization energy. Now we will discuss about the group trend. Trends of ionization energy down the group. It must be noted that when we move down the group, there is first of all increase in atomic size due to addition of new shells. Similarly, there is also the increase in the screening or repulsion of the outer electrons by the inner electrons. So there is increase in the screening or shielding effect due to presence of the large number of inner electrons. So these two factors, that is increase in atomic size and increase in the screening effect when we move down the group, tends to decrease the value of ionization energy. क्योंकि जितना ज्यादा atomic size होगा और जितनी ज्यादा screening होगी उतना ही nuclear force कम होगा. So जितना nuclear force का value कम होगा, smaller will be the value of ionization energy. So we can simply say that when we move down the group, there is decrease in the value of ionization energy. So this is the trend of the value of ionization energy when we move down the group. Now students, this was the second lecture about the ionization energy. इस टॉपिक से बहुत सारे क्वेश्चंस आपके 11th क्लास में पूछे जाते हैं और नीट या JEE में पूछे जाते हैं. सो मेरे साथ कनेक्टेड रहने के लिए मेरे यूट्यूब चैनल केमिस्ट्री विद सजाद सर आप सब्सक्राइब कीजिए और तमाम फ्रेंड्स और केमिस्ट्री लवर्स तक इस यूट्यूब चैनल को शेयर करना ना भूले. थैंक्स, हैव अ नाइस डे.